Hi everyone! In this video, we are going to explore 3 common proof strategies in computer science. First, we are going to start with direct proof, and then we are going to explore 2 indirect proof strategies, contrapositive and proof by contradiction. Before exploring these proof methods, let's have a quick refresher on logic notation. A proposition or a statement is a sentence that can be either false or true. It cannot be both, it cannot be neither. It cannot be a question. We use letters P, Q, or R to represent propositions. Not P is negation of P, and so if P is a proposition which is evaluated to be true, then negation of P is false. Also, if P is false, then we know that negation of P is true. P or Q is false if both P and Q are false, and it's true otherwise. P and Q is true if both P and Q are true, and it's false otherwise. P, X, or Q, which is known as exclusive OR as well, is true if P and Q have different values. So if P is false and Q is true, it is going to be true. But if P and Q both are true, it is going to be false. The next one is implication, or P then Q. If P, then Q. If P, then Q is true if P is false or Q is true. So the only case that P then Q can be false is when P is true and Q is false. The last operation is P if and only if Q, which is true if both P and Q hold the same value. So if both of them are true, P if and only if Q is true, and otherwise it is false. We can summarize the whole thing in a table that we know as a truth table. You can see the truth table covering all of these cases here. The first proof strategy that we are going to learn is direct proof. So direct proof is P then Q. So we are given some information and we know them as P, and then we want to show Q is true as well. So let's see one example. The first example that we can cover is the case that if n is even, then n square is even. We can use direct proof to prove this statement is correct. So here the P part is if n is even. We know if n is even, then there must exist some integer like k such that n is equal to 2k. If n is equal to 2k, then we know n squared is 2k squared. 2k squared is equal to 4k squared, and we can write it as 2 times 2k squared. Since k is an integer, k squared, and so 2 times k squared is an integer as well. So we can write it as 2t when t is equal to 2k squared. Since 2t is in the format of an even number, then we can say it is even. So we just show that if n is even, then n squared is even. As you see here, P is n is even, and it is our assumption, and Q is n squared is even. Now let's learn about indirect proofs. Sometimes it is not easy to start from P and reach Q. In these cases, we need to use indirect proofs. 2 indirect proofs that we are going to cover here are contrapositive and proof by contradiction. So let's talk about contrapositive. If we have P then Q statement, it is known that it is equivalent to not Q indicates not P. These 2 statements are equivalent. We can show it in a truth table, or we can actually think about that. Let's say we have P statement as today is Monday, and Q is I have discrete math class. So P then Q is if today is Monday, then I have discrete math class. Now let's think about not Q then not P. Not Q then not P says if I don't have a discrete math class today, then it means that it is not Monday. Note that since on Mondays you have discrete math class, if you don't have a discrete math class, then it means that it is not Monday. We don't talk about exceptions here, like what if it is Monday but the class is cancelled. So we are talking about a general case. So since 2 formulas or statements are equivalent, I mean P then Q and not Q then not P, sometimes it is easier for us to use not Q then not P. Let's see an example. The example for contrapositive that we have is showing if n square is odd, then n is odd. So, okay, let's start with direct proof to see if we can use direct proof to solve it or not. In this example, P is n square is odd and Q is n is odd. So, okay, I know n square is odd based on my assumption P. If n square is odd, there must exist an integer k such that n square is equal to 2k plus 1. But what can I say about n? N is a square root of n square, so I can write it as a square root of 2k plus 1. But is there any way that I can simplify a square root of 2k plus 1 to know if it is odd or even? Not really. In this case, it is easier for us to use contrapositive. Contrapositive of this statement is similar to what we proved for the example as direct proof. If n square is odd, then n is odd is equivalent to if n is not odd, then n square is not odd. I can also say it as if n is even, then n square is even. It is exactly the same thing as our last example, and we already proved that. Since we can prove that and it is equivalent to its contrapositive, then we can say if n square is odd, then n is odd as well. The last proof strategy that we are going to cover is proof by contradiction. Proof by contradiction is very similar to contrapositive, but not exactly the same. Actually, we can say contrapositive can be a special case of proof by contradiction. Proof by contradiction says you want to show if P, then Q. And it is not easy to do that using direct proof. Now, let's assume that Q is not true, so not Q is true. Then start from there and show that either P cannot be true or some fact in mathematics that everyone knows is true is going to be false. And it contradicts some mathematics rules or the assumption that we had. So, starting from not Q, we are going to reach either not P or a contradiction to some well-known fact in mathematics. Let's see one example here. For proof by contradiction, we start with an example. This example is a very common example in mathematics and computer science to show proof by contradiction strategy. Show that a square root of 2 is irrational. Before diving into the solution, I want to give you the definition of irrational numbers. An irrational number is a real number which is not rational. So actually I can tell you that there is no formal definition for rational numbers, and its definition depends on the definition of rational numbers. So let's see what a rational number is. Rational numbers are the numbers that we can write as a fraction where both parts of the fraction are integers and the denominator is not equal to 0. If we can write a number as a fraction with both integer parts and the denominator is not 0, we can say the number is rational. Any other number in real numbers is irrational. So here, since we want to show a square root of 2 is irrational and we don't have any formal definition for irrational number, it is a good idea to start with proof by contradiction. So we assume that a square root of 2 is not irrational and so is rational. If a square root of 2 is rational, then there must exist two numbers like a and b which are integers and b is not 0, and a square root of 2 is equal to a over b. We want to add another restriction to this definition. If I have a fraction, then I can make it simple by dividing both parts of the fraction over their common factors. Let's assume a and b have no common factors or they are prime to each other. For every fraction, we can divide them by their factors over and over until they become prime to each other. So it is not some restriction that we cannot apply on a given fraction. So now that we know a square root of 2 is equal to a over b, we can say 2 is equal to a square over b square, which means that 2 times b square is equal to a square. Note that the left-hand side is even and it is equal to a square. So we can say a square must be even as well. If a square is even, then it means a must be even. And if a is even, then it means that there must exist an integer like k such that a is equal to 2 times k. And a square is equal to 4k squared. We knew 2b squared is equal to a squared. Now we can write it as 2b squared is equal to 4k squared. Dividing both sides by 2, we can say b squared is equal to 2k squared. Note that now right hand side or 2k squared is even, and so b squared must be even, which means b is even. And it is a contradiction since now we know b and a are both even numbers and so they have a common factor of 2. But we assume that they have no common factor and they are prime to each other. It is a contradiction and it means that a square root of 2 cannot be rational and it must be irrational. It is an example of proof by contradiction. Thank you for watching this video. In the next video, I'm going to talk about proof by induction, which is another useful and common proof strategy in computer science.